in class and you won't have homework. You have enough information in your mind and your brain right now that you should be able to do all this, but we're going to run through them because yesterday after yesterday, apparently we need a little bit of practice with it. So here we go. So simplify, and I'll even use the ones on your sheet as examples as I run through of what we do with each one. So first thing is simplifying. Now, this is where we don't kill kittens, okay? No killing kittens here. As long as you are multiplying in the top and the bottom of the fraction, you can cancel things out. In other words, if I have something like x plus 3, x plus 1 over x plus 1, x minus 4, I can cancel the x plus 1's out. Are y'all aware of this? Okay, so we can cancel out factors, but here's the key. Everything, before you start canceling, everything, not everything, every plus or minus needs to be in parentheses. And what I mean is, if you have something like, you see the poster up there where it says, bless you, x squared plus 2x plus 1 over x squared plus 3, and it does this and says every time you do this, a kitten dies. Those plus or minuses are, oh my gosh, those plus or minuses are not included in parentheses, so they don't just cancel. It would have to be like that, and then I don't have another x squared plus 2x plus 1 in the bottom, and I don't have another x squared plus 3 in the top. So nothing cancels there. This is, side note, you know. No, this is not in your book.
You'd be like those people that tell the commercials. No, like in a commercial.
This is an Algebra 2 thing. All right. Thank you. Carter, you are distracting. All right. So here's what we're going to do. We're going to completely factor top and bottom if we can. Okay? So take a look at that first one. Yeah. Tell me when you got it. We're waiting on Lucy to copy it. That's okay. It's okay. You factor everything you can. Well, does x squared? Oh, yeah, you can. You can. What multiplies to 1 but adds to 2? 1 and 1. It's a perfect square trinomial, right? But you can't factor the bottom. So what cancels? Nothing, right. So we're going to look at one that something does cancel on. Okay. What? We don't know. Noah's just Noah. Go ahead, Mike. Remember it, so it's what multiplies to 1 but adds to 2. Positive 1 and positive 1. All right. Look at number 1 on your sheet, though, because that one's going to be factorable. Yeah, do it on your sheet. Do it on your sheet. N squared minus 4 over n squared plus 8n minus 20. How does the top factor? Come on, guys. Y'all can do this. Carter.
N minus 2.
N minus 2.
N plus 2.
Thank you. What is that called? A what?
Relative.
Thank you, Maddie. A difference of 2 squares. Now, on the bottom, how's that one factor? What multiplies to negative 20 but adds to 8?
10 and 2.
10 and 2, but one needs to be negative. Which one? Oh, these are the same, so they cancel, right? I couldn't cancel here because I'm not in parentheses. But over here, these two factors can cancel, so I'm left with n plus 2 over n plus 10. Can I cancel these n's now? No. But now that they're in parentheses, could you do it? The point is you can only cancel things that are being multiplied. Well, the only way, so you put the parentheses around them, but then it's got to match top and bottom. What's inside the parentheses has to match top and bottom for it to cancel out. No, that's the final answer. That's simplified, okay? Shut up.
I just looked here and like put it in and take it out. I was like, he's gonna be about to go to sleep.
All right.
Trying to sharpen a pen.
I'm moving on to the multiplication that follows number 6. Now, rational expressions are just fractions, and when we multiply fractions, we multiply top times top and bottom times bottom. The key to all of these problems are going to be factoring, whether that's taking out a GCF, whether that's factoring a special pattern, or factoring the quadratic. It's all, the key is factoring. So, top times top, bottom times bottom, and then we simplify. So we have 8 over m minus 5. So I could put a parenthesis around this m minus 5, right? Say right, because that's right. Times 5m minus 25 over 5m plus 50. Yes, you can, but what I want to do is I always want to factor first, anywhere I can. Remember, factoring is key here. Factoring is our favorite F word, yes. Thank you, Lucy. Always going to remind me. I shall never forget. I'm going to make a sign that's going to say factoring is my favorite F word. It could go right over that board right there. What can I factor here? Anything? This one I could take a 5 out, right? Anything else? Yep, I could take a 5 out. So what I really have now is 8 over m minus 5 times 5 times m minus 5 over 5 times m plus 10. Do I need to get my stapler ready to hang up another perfect example of cheating?
Not.
What?
This isn't your class. It's only for the questions I wasn't here for.
So they should just count the questions you were here for. That would be fair though, right? Top times top and bottom times bottom.
Don't worry.
What? Why did I change colors? Is that what you said? All right. Now I'm gonna cancel out what I can, and I'm gonna work on simplifying this. Okay. It's just in the front now. Okay. It did. This means if there's no sign in between, that means multiply. Now watch what happens. All my plus or minuses are enclosed in parentheses, yes? So I can start canceling things out. $40 divided by 5. If this was the fraction, 40 over 5, how would that reduce? 8 over 1, right? So I have 8 up top and 5m plus 10 on the bottom. I don't know. Sorry. I am just tired by this time of day. You get this? Do you get the addition and subtraction? Like number. Wow. Let's look at 11 first.
I think we should.
Carter, move that book right there. Move. Remember, the very first step in all of these is going to be to factor completely, okay? Do you see anything here that can be factored? What? What does it become? Now, here's where things get confusing. I am adding or subtracting fractions, right? When I add or subtract fractions, what has to be the same? The bottom, okay? I need to make the bottoms the same so that I can combine the tops. If you get confused, think about a basic example like 2/3 plus 3/4, right? I can't combine them like that until they have the same denominator. I'm going to have to do the same thing here. I'm going to have to force them to have the same denominator. How? Well, what do you do here? I could multiply this by top and bottom, and this one by top and bottom. So I'm going to do that same thought process here. I'm going to multiply x plus 1, x plus 2. Same way I did it over here with a basic one. This one I'm going to give a 2. Y'all okay? Now I have 3x, x plus 1, x plus 2, minus, oops, let me put it over. Don't start canceling them out. I have two fractions that I'm subtracting now that have the same denominators. Once the denominators are the same, we just combine the tops. I don't know either. I don't know what's going on. I have 3x times x plus 1 times x plus 2 minus 10.
The amount of stuff I've done today is amazing. I've done 4 mood boards.
Can I cancel the x plus 1 and x plus 2 out now? Why? That was not enclosed. I can't do it. Can't do it, Captain. That minus sign is off on its own. So the only option I have here is where the real work comes in. Are y'all ready? Huh? You can't just put a parenthesis anywhere you want to. You can enclose everything, but that's not going to do me any good. It's not on there because it was its own fraction over here. So when you're adding or subtracting like this, you have to expand before you can simplify. It does expand the numerator. Leave the bottom alone. The bottom is already factored completely, right? It's the top that's not. So how do I expand that? Y'all are killing me. Killing me. I'm just multiplying that top out. So I just FOILed out here, and now I have x squared plus 3x plus 2. I'm just going to keep going. Y'all will get mad at him and soon enough. And now I'm going to multiply through. All I did was FOIL out those two binomials. Glad I could help you with that, buddy.
I thought you said bracket. You say bracket.
At this point, I would look to see, can I factor it or simplify it any so that I could cancel things out? I would do a slash here. It would leave me with x squared plus 3. I could take 2 out. That would leave me with 3x minus 5. So it's not even going to factor. So this is my final answer. Adding and subtracting is the hardest. Then we talked about complex fractions yesterday. These are a little easier though. That's what we're fixing to do. All right, so that takes you up through number 15. When we start at 16, we're into what we call complex fractions. And here's what we're going to do. We're going to look at this as 3 separate problems. So I'm going to start with 16. It is x plus 4 over 36 minus 2x over 3 all over x squared over 18 minus 36 over x plus 4. So we're going to look at this separately, okay? We're going to do the top, then we're going to do the bottom, and then we're going to do the top times the flip of the bottom. And we're going to simplify each a step along the way. So let's look at just the top. X plus 4 over 36. This is just like the ones we just did. We need to get a common denominator so that we can combine them. This particular one, the top of this one, is a little bit easier because these are just numbers. If I need to make these look the same, what do I give where? 12 to the 3. That's exactly right. So I give this one a 12, and if I give this one a 12, I have to take it to the top as well. So I have x plus 4. What? I could make the 3 look like the 36 by multiplying by 12. Now I have 24x over 36. These are not going to come out nice, pretty answers because they're just from a program I have that just generates problems. If I combine the numerators now, x plus 4 minus 24x would be negative 23x plus 4 over 36. I can't simplify that any further. How? Can't do it to the 23. That's not fair. The bottom's another story because it's a little bit more complicated. X squared over 18 minus 36 over x plus 4. Who do I need to give what? That's right. Remember, what I'm really doing here is multiplying. This would be x to the 3rd plus 4x squared was 36 times 18. Robert doesn't have it because he doesn't have his calculator. And now I can just combine them over the same denominator. No, Coach Beckley's in the bathroom. He calls himself the BBB, the boys' bathroom bouncer.
I remember one time I was in there and he just walked out and was like, hey, turn on.
I always want to check to see if I can factor it any further or do anything else. I'm good to go. Yes. Nothing else. Everybody good? But I'm not. If you can't factor it any further. Say again? We got to combine. That's right. You're exactly right. We have to do the top times flip the bottom. This is what we were doing yesterday. I'm sorry. Because instead of dividing by the bottom, because this is a fraction, top divided by bottom, I just do top and then multiply by the reciprocal of the bottom. What was it, plus 4? Since you have worked so hard to ensure that everything is completely factored, you're not going to multiply anything out at this step. All you're going to do is mark things out if they mark out. Here, nothing marks out, but 36 divided by 18 does reduce. What does that reduce to? 2. Multiplying fractions, really, when you're in rational expression land, if you're multiplying top times top, bottom times bottom, make sure everything's in parentheses and just make it one big fraction, because that's really what you're doing. You're multiplying. So you get 2. What's wrong, Robert?
Yeah, that's what I was confused
Yes, my answer is just going to be, it matters. I'll flip my answer. Yes, yes. It's going to be, here's what's going to happen, because I accidentally did top times flip bottom instead of, I accidentally did flip top times, it's going to be flipped over. It's going to be x plus 4, negative 23x plus 4 over 2 x cubed plus 4x squared minus 16. This is confusing. Let me start over because I lost everybody. What's the top? The bottom. Flip it. Flip it. $18 divided by 36 is 1/2. Does that help you see it? Okay, let's do one more. Let's do 20. I gotta scroll out so I can see my top and bottom. Let's look at the top first. All right, somebody said 5 on the right. That's correct. So I have m plus 3 over 5m plus 5 over 5m. Agree or disagree? Why? Put tops together. Can I do anything else with it? No. Circle it. Robert, are you that excited about this problem? Bottom. Who needs what? Okay, so, well, you got to look at it as a whole piece, as m plus 3. So if I think about my common denominator is going to be m times m plus 3. That means this one needs an m, and this one needs an m plus 3. So I have m squared over m times m plus 3 minus 5 times m plus 3 over m plus 3. Yeah. All right, let's combine the tops. Can I start canceling anything out yet? No, why? Because of that. So instead, I have to distribute. I have to expand before I can condense. So I have m squared minus 5m minus 15 over does that factor? No. Can't cancel anything out, nothing factors, so I'm done with the bottom. Now I put them together. Together, yeah. Y'all are not having fun now. Top is m plus 8 over 5m. The bottom, flip it, m times m plus 3 over m squared minus 5m minus 15. I do see one thing that cancels here. Yay. What does? The m. I'm left with m plus 8. The m that's on the outside all by itself, because it's being multiplied and it's in the top and the bottom. If that happens, yes. Now I'm done.